In class, we worked with two equations shown down at the bottom to figure out how much energy is stored in a cart and how much energy comes out of the cart when it's released from the top of the ramp. So those are potential and kinetic energies, right? At the top of the ramp, our cart has stored energy due to its position above the ground and the gravitational pull of the Earth. The Earth pulls all objects down at a rate of 9.8 meters per second squared. What that means is simply that when an object is falling because gravity's pulling it, every second that it falls, it's picking up about 9.8 meters per second of additional speed. So you can see a separate tutorial on why g is what it is and why it's called the acceleration due to gravity. So if this number up here in the corner is bothering you and you want to know more about it, you can watch that separate tutorial. But all you really need to know is what that number actually is, and that's the number that appears in the PE equation. The potential energy equation has g in it, and it's a constant. It's just a number you have to memorize. It's 9.8, and the units for it are meters per second squared. Now, the other two things that are in the PE equation are an m, which stands for mass, and an h, which stands for height. The mass is the mass of the object that is being held above gravity. In this case, it's a cart. And we got the mass of our cart in grams, but we have to convert that to kilograms because our PE equation only works if all our units are in the right format. So they can't be in grams, it has to be in kilograms. So I said the way to convert grams to kilograms is just to divide by 1,000. So when you do that, 520 becomes 0.520. So 0.520 is going to be the mass of the cart in kilograms. So that's what m is equal to. So we know what m is, we know what g is. Here's g, here's m again, here's g. So we need to know h, the height above the ground, and that's given to us here. That's the height of the ramp. So the height of our ramp is 4.0 meters. So now we have all the information we need to plug into the PE equation, and we just have to multiply those three things times each other. So we're going to multiply 9.8 times 0.520 times 4.0. And you should have this in your notes that you did that. And when you multiply those three numbers times each other, you're actually going to get 20.384 as your number. I'll show you what that looks like. You should have this in your notes. The first step, write the formula, PE equals mgh. Second step, plug in the numbers. Your mass is 0.520 kilograms. I'm going to put that in parentheses, just so it's easy to look at. G is always the same number. It's 9.8 meters per second squared. Notice how I'm including my units. And my height, which I'm sort of running out of room for, is 4.0 meters. Just barely squeezed it in. Third step, plug those numbers into your calculator. You're just multiplying straight across. When you do that, you're going to get 20.384. And now you got to look at the units, which is a little bit tricky because you're probably not used to multiplying units, right? So when you multiply a bunch of letters times each other, the only letters that are going to change are going to be the ones that are doubled up. So watch. What we have here is a kilogram times a meter times a meter. That's going to give me a kilogram times a meter squared, because that's what a meter times a meter is. It's a meter squared. And I have to look to see what I've divided by. I've divided by seconds squared, so that stays the way it was. Those units are probably the most confusing thing about all of this. And the way that you get those units is just by carefully looking to see, okay, what did I multiply by what? I multiplied a kilogram times a meter, and then I divided by seconds squared. And it's important that you write out those units because those units are the units of energy. That's what they are. They're kilogram, meter squared, second squared, which sounds terrible, which is why, instead of calling it that, we change the name to joules. But first we need to round our numbers. So we started out, we have two numbers that we measured. This one is the height, and this one is our mass. This number here is not really a measured number. That's a constant. That's just the acceleration due to gravity. So that number doesn't count as a measured number. We want to look just at our measured numbers and ask ourselves this question. Which measured number has fewer digits? Answer, 4.0. It only has 2. 0.520 has 3. So 4.0 meters has only 2 digits. That means my answer can't be this many digits long. It can only have 2 digits. So I'm going to round to 20. So 20 is going to be my number answer, but my units are going to go from kilograms, meters squared, seconds squared. They're going to turn into joules, because that's what a joule is. 1 joule is equal to a kilogram times a meter squared divided by a second squared. And this would be the answer to how much potential energy my cart has at the top of the ramp. Now, this is all just what we call plug and chug. There's nothing scary about it if you just take it one step at a time. Write your equation, plug in your numbers, multiply it out. This is the step that'll probably trip you up the most. That's okay. Just do the best you can. Look to see if you can figure out, wait a minute, did I get kilograms times meters squared divided by seconds squared? You should, if you did it right. And then the last step is just to rename your units, joules, and round to the right number of digits. After we calculated the potential energy of our cart, we needed to calculate how much kinetic energy we were going to get out of it once it started to roll. To do that, we needed this formula. Kinetic energy is equal to 1/2 the mass times the velocity squared. So this time we're going to use 8.0 meters per second, because that's our average velocity of our cart. We're going to plug that in here. Our mass is the same as it was before, 0.520 kilograms. That's going to get plugged in for our mass. So when we do that, we're just going to get a simple equation that looks like this. KE equals 1/2 mv squared. So plugging in our numbers, we have 1/2 times our mass, which is 0.520 kilograms. That's the mass of the cart. And our velocity is 8.0 meters per second. Oops, ran out of room there. And that's squared. So now we can plug these numbers into the calculator. We have to square 8, that'll give us 64. And then we're going to multiply 0.520 and 1/2. And that'll come out to, let's see, I already have this done somewhere, 16.64. And my units are going to be kilogram times meters squared divided by seconds, also squared. Again, that's the right units, right? That's what a joule is equal to. And you got that by multiplying your kilograms here times your meters per second. And then squaring the meters per second. That's how I went from meters per second to meters squared, seconds squared. That's the hard part, right? But if you were to mess up that one part, it wouldn't be that big of a deal. As long as you get to this part, you should be okay. Next step, you have to round to the right number of digits. So our original numbers that we measured are this one over here, that's our mass, and this one over here, that's our velocity. Our mass has 3 digits in it, and our velocity has 2. So our answer can only have as many digits in it as the weakest of our original measurements. So we only get 2 because 8.0 only has 2. So 16.6 is going to round up to 17. And a kilogram meter squared per second squared is going to become a joule. Now, according to the law of conservation of energy, the energy at the top of our ramp should equal the energy we get out of the ramp at the bottom. But when we calculated out our potential energy, which is what we had at the top, we had 20 joules of energy. And when we calculated out our kinetic energy, or energy of motion, we only had 17 joules of energy. So somewhere along the line, we lost 3 joules of energy. Where'd it go? It's a good question, right? Well, if you think about it, kinetic energy comes in different forms. And the form that we've measured here with this formula is the actual mechanical energy of the cart moving, and that we know that because we're using velocity to calculate it, right? This is the velocity here in the equation. So we have 17 joules of mechanical energy, mechanical kinetic energy. So there must be 3 joules of kinetic energy that are some other form of energy that we weren't able to measure with our cart. And those 2 forms are heat or thermal energy, and sound. As the cart rolls down, the board underneath it is actually going to warm up a little due to friction. And you'll hear it move, right? You'll be able to hear the sound of the wheels moving over the cart. So there's a loss of energy. Not all the energy of the cart is going to be kinetic mechanical. Some of it's going to be kinetic heat or thermal. And some of it is going to be sound energy. The lab that you're going to do is going to have you calculate how much energy is lost due to heat and sound. And the way you're going to figure that out is you're going to figure out what the potential energy of your cart was, and then you're going to calculate how many joules of kinetic energy you got out of the cart, and by subtraction you'll be able to figure out how much was given up to heat and sound. Okay, hopefully that helped you understand a little better what to do with these formulas, and I will see you in class.